Assalamualaikum and hi, my name is Muhammad Irfan bin Edi Syahril. Today I'm going to share with you guys about experiment that I did previously. Okay, the first one is experiment DC1. This experiment aims to determine the internal resistance and assess the precision of a 12 manometer, a device used to detect and measure small electric currents. The internal resistance of a 12 manometer is the resistance within its own coil and circuit elements. Therefore, measuring this resistance is crucial to understand how the galvanometer behaves in a circuit. This experiment is divided to 4 parts, A, B, C and D. The first one, DC1A, is to measure the internal resistance in a galvanometer. For the part B, is to determine the sensitivity of the galvanometer, while for part C, to determine the resistance when the voltmeter is connected in parallel to the resistor and ammeter, and last but not least, part D is to determine the resistance when the voltmeter is connected in parallel to the resistor only. So, the apparatus that I use in this experiment is battery 2V, switch, resistor box, resistance 10 ohm, resistance with 470 ohms, resistance with 8.2k ohm, and galvanometer, ammeter, voltmeter, rheostat and wires. For the experiment O2, when light travels from one medium to another in different speed, the direction of the light path can be changed. It's due to differences in density between two mediums. If the light travels from a less dense of medium to higher dense of medium, the refracted light bends more towards the normal line. Moreover, the light ray doesn't refract if the light wave approaches the boundary in a perpendicular direction, despite the change in speed. Next, there are 3 objectives of this experiment that I found. First, to observe how light refracts and disperses when it passes through a prism. Second one, to study how light behaves when it travels through prisms made of materials with different densities. And the third one is to measure the angle at which light refracts as it passes through a prism. The apparatus that I use in this experiment is collimator, magnifier lenses, sodium light source, spectrometer, glass prism and telescope. For the third experiment that I did is experiment M2, measuring the rigidity modulus of a wire by using Maxwell needle method. What is Maxwell needle method? It's a scientific instrument that is used to measure the amount of the modulus of rigidity of wire when a wire is stripped at one of its ends and hang with a horizontal cylinder at the bottom end of the wire. This system is moved by twisting in a horizontal plane, and the formula for the period T from one oscillation is T equals to 2 pi in bracket 2 Li over pi nr to the power of 4, and the bracket will be to the power of 1 over 2, where L is the length of wire, I is the moment of inertia, N is the rigidity modulus of the wire, and R will be the radius of the wire. The objective of this experiment is to find the rigidity modulus of wire using Maxwell needle method. And the apparatus that I used is Maxwell needle, of course, retort stand, wire, screwdriver, screw bridge, sellotape, metal ruler, solid cylinder, hollow cylinder, electronic balance, and stopwatch. Next, experiment MP1 photovoltaic cell. I use a PV cell that is constructed from the semiconductor material. When a photon hit this PV cell, they will be reflected, pass through, or actually be absorbed by the semiconductor. Therefore, only the absorbed photons will provide the energy needed to generate electricity. When the semiconductor material absorbs sufficient sunlight, or I would say solar energy, it will dislodge electrons from the atoms within the material. This material is specially treated during manufacturing to make the front surface of the cell more receptive to these freed electrons, to allow the electrons to migrate naturally to the cell surface. The objectives for this experiment is to see how the current is affected by the distance and how it changes depending on the cosine of the angle, And meanwhile, the apparatus that I use are ammeter, DC power supply, meter ruler, protractor, photovoltaic cell, which is made from selenium, wires, and light bulb. Last but not least, the final experiment that I did is experiment 03, which is diffraction rating. So, a diffraction rating is a tool used in optics that helps separate lights into its different colors or wavelengths. It works by having many tiny, evenly spaced slits that allow light to pass through. When light hits the grating, it bends and spreads out due to diffraction. These slits act like multiple small light sources, causing the light waves to overlap and interfere with each other. This interference produces a clear pattern of colors which can be used to study the spectrum of the light. Then, the objective for this experiment to understand the use of diffraction rating in the formation of spectra and in the measurement of wavelength. Other than that, it is to investigate continuous spectrum while also to find the grating constant. The apparatus that I use are collimator, telescope, spectrometer, ordinary frosted bulb, diffraction grating, and mercury lamp. Mind that we can change the mercury lamp with other lamp that has high intensity. If it's low intensity, then we can use it to change the mercury lamp. I think that's all for now. Bye bye.